calculations, it does say at the beginning of section B to show all of your working for calculations. So you do need to make sure that you show your working and show it clearly, because the examiners need to actually be able to follow what you're doing. It's a good habit to write down the equation that you're using first and then substitute your numbers. When you get to the end of your calculation, of course, don't forget that there will be some units, whether it's moles or moles per litre or grams or millilitres, whatever it is that you're calculating. Make sure that you put your units in at the end, because perhaps marks aren't going to be awarded unless we know what units you're expressing that in. Now, somewhere on the paper there's always a question that we mark the significant figures. So you need to make sure, really, throughout all calculations in the paper, because you don't know which one it's going to be, that you're always giving your answers to the correct number of significant figures. Very often the question will have, for example, 25.0 mils of an acid was titrated. The concentration of the acid was, let's say, 0.156, and everything there, all that data has been given to you in 3 significant figures. So that means that really your answer should be also to 3 significant figures. So look after your significant figures in all questions, and don't round off your answer until your very final calculation. Keep your numbers in your calculator. Use your memory on your calculator to make sure that you've not, inadvertently rounded down somewhere before the final answer. And then just check that your answer sort of makes sense, like logically that it's making sense, that you're not getting, some huge volume of a gas produced if you've only used such a tiny mass of substance. So think about what it is that you're calculating as well. You might get asked in the paper somewhere to draw a specific diagram, or perhaps when you're answering a question, a diagram might help. Remember, diagrams can often save you 1,000 words, particularly if you're trying to outline a procedure for a particular experiment. If you're asked specifically for a diagram or a labelled diagram, make sure that your labels actually touch the piece of equipment that you're labelling, as opposed to just pointing to some, point in mid-air. For example, also with, in the past they've asked questions like, draw the setup for reflux. So you've drawn your condenser and your round bottom flask, don't forget your heat source, but then it's not going to miraculously stand up by itself. You'll need some sort of support, so make sure that you also include in your diagram, your clamp stand, that type of thing, and label everything, right? Label as much as you can. And make sure that your diagram is sort of kind of roughly to scale, but make sure also that it's 2-dimensional. For instance, when you draw the condenser, you've got to remember to leave the top of the condenser open. So make sure that you haven't, put a bung in or something like that, or simply just closed off the top in your diagram. They don't need to necessarily be, the neatest of things in terms of using a ruler. I mean, it's a good idea to use a ruler, but if you're rushed for time, then, just try and get the general setup of that equipment down on paper. If you haven't been asked to draw a diagram, then, like I said, it's quite a good idea to quickly sort of slip one in, because it can actually say quite a lot of things for you. One of the commonest errors, I suppose, in the chemistry paper is writing equations and formula and writing the correct formula. For instance, students notoriously seem to get confused with ammonia and the ammonium ion. So if you're writing ammonia, you're writing NH3, and if it's the ammonium ion that you're talking about, it's NH4+. So make sure that you're familiar with the polyatomic ions and that you can write chemical formula correctly. Practice that. Practice all of your common polyatomic ions. For example, your phosphate ion, your carbonate ion, your ammonium ion, your sulfate ion. Think about your ions that you're using for your buffers, and think about your ions that you're using when you're looking at amphiprotic species. So make sure that you know those ions and you can write their formulas correctly. Some equations sometimes are better off written as a structural equation. For example, if you're writing an equation for esterification, it means more if you write it as a structural equation. So write out your alcohol and your acid And then across your arrow, don't forget to think about the catalyst in your equation. So you're going to include, for that particular reaction, your concentrated H2SO4 as your catalyst. And draw out your structural arrangement of your products. Be careful with those equations as well, particularly if you're asked for structural formula or structural equations, to include all of the hydrogens on the bonds. You know, often in class you're just writing the carbon backbone with the dashes because you're being quick to write down the structural formula. But make sure that you're including all of the bonds in your actual structural formula. So don't be lazy, otherwise you'll be throwing away marks.